like this.
It's time now for our science and technology slot, and the focus today is on the Center of Excellence, which uses mathematics to understand and predict the development of diseases. Now, the center also provides advice on how best to combat those diseases. And joining us to elaborate further is Ms. Cindy Carvalho, who is a master's student at the School of Computer Science and Applied Mathematics. Good morning, Ms. Carvalho. Thank you for joining us. Welcome.
Thank you, Rowena. How are you doing?
I'm very well, thank you. But before we get started on our conversation, I'd like your views on the discovery of the fossils of Homo naledi. I think we split right down the middle on this one in terms of our evolution as a human race.
Yes, it's such exciting news to be finding out these new research areas that have now come into play, and it's quite exciting that it's in South Africa. So we all here at WITS are all very, very, very excited about that.
Because the people who are saying this has got nothing to do with us as humans, it's got nothing to do with with the fact that with us, with mankind or humankind.
No, definitely. I definitely think that it does have to do with us, and it's just so exciting that we're finding such great research topics in South Africa. I mean, this is the melting pot of future research developments in this area.
Oh, wow.
This is where it's happening.
Let's talk about what you are directly involved with. Let's talk about the Centers of Excellence. I think they were launched about 10, 11 years ago by the Department of Science and Technology and the National Research Foundation. Yours was actually launched 2 years later in 2006, which is the Center of Excellence in Epidemiological Modeling and Analysis. Tell us more.
Sorry, in terms of the Center of Excellence that we've launched, it's currently the Center of Excellence in Mathematical and Statistical Science.
I see. Okay.
Which was launched in 2014. So we were established in 2014. It's the Center of Excellence in Mathematical and Statistical Science. And the center focuses on using various mathematical and statistical tools to solve real-world problems of social significance. So one of the leading themes that the center has been focusing on is the mathematical modeling of diseases such as cancer and HIV, which is
all right. And break it down for us and make me understand, how does mathematics help to predict the development of diseases like cancer and HIV, like you say?
Right. Okay. So let me give you an example. For example, if we're taking into consideration HIV and AIDS. So the mathematical modeling of that, what happens is, in terms of resources, we have very scarce resources in terms of ARVs and how we distribute it. So it's important to observe how the diseases such as AIDS advances in certain areas, certain regions. So by studying the spread of the diseases in different communities, we can identify key hotspots to target in order to optimally distribute the ARVs. Okay, so we can see how the disease is going to develop in years to come, so that we can provide some further information to the appropriate authorities so that they can make more informed decisions regarding strategies in controlling diseases such as AIDS.
I don't think I still quite get how mathematics is used, though, as a tool for that.
All right. So in terms of the mathematics, it's like computer simulations. So it's called, there's one type of model called an agent-based model, where you have different regions, and in terms of, there's these agents that we create on a computer system, and each agent has a certain risk factor, and they have certain environmental factors that contribute to them being more susceptible or not. And you instill a person maybe in one region that has the disease, whichever disease it is, and you see how, doing many simulations, you see how this disease actually propagates in certain areas. So if, for example, you were in a region, an area where there's not a lot of, not a highly dense population, right? And you had a disease such as TB going around that can be transmitted maybe through just coughing or something, and then you put into another region with a highly dense population. How does the different regions, taking into consideration what disease you're dealing with, how that disease actually develops? How does it spread? How quickly does it spread? because that's really key for us to know the development of the disease. How many people will get it in 5 years' time? What will the numbers be in 10 years' time? In order for appropriate authorities like the Department of Health and so on to be able to combat this disease as effectively as possible.
All right. Given the examples you are making, I'd assume that you've been working in the field of HIV and tuberculosis primarily.
I personally haven't. My research field is actually focused mainly on mathematical modeling of tsunami behavior. So I'm looking at waves, run-ups on beaches, but I do have a few colleagues that have been working in the modeling of HIV and
all right.
AIDS.
Let's talk about what you particularly do, just briefly, the tsunami of waves, you say. What's that about?
So my research is focused predominantly on mathematically modeling tsunami behavior. So specifically looking at how the wave approaches the beach, as it is approaching the beach, how far can we expect it or predict the wave to run up on the beach, as well as determining the speeds at which these waves hit the shores. And we would think, why is this important in a real-life situation? If you looked a few years ago at the tsunami that hit off the coast of Japan, you saw there were safe zones that were created. Now, these safe zones, so if there was a tsunami alert, the people were taken, they were told to go to these safe zones, so there's evacuation routes and so on. So if you have these safe zones and they're not high up enough, obviously they won't be safe anymore. So as the tsunami comes and it hits shoreward, the people's lives will still be in danger. So optimal strategies for evacuation routes and all of that rely heavily on how far the tsunami will move inland and at what speeds it will hit.
All right.
So this is particularly what I'm dealing with.
But we're not prone to tsunamis in South Africa, are we?
No. We, thank goodness, we're not prone to tsunamis in South Africa.
And why is that?
There's quite a few reasons for that. You can ask more the geography people. I just usually work on the maths, but I know it usually happens more in your warmer waters. So it's more off the coast of Asia and all of that. So in terms of us, we don't usually experience tsunamis, but it's a very interesting topic to be looking at the moment. In America, they're doing obviously a lot of this type of modeling, but this is just one of the research topics that have been flourishing at the moment, and it ties in nicely with one of the themes that the CoE actually are working on, which is mathematical modeling of the Earth and the environment. So it's one of the key themes reflected in the CoE.
All right. You mentioned that you've got a couple of colleagues who work on the development or, research into the development of diseases like HIV and tuberculosis and cancer and so on. And what are they saying in terms of the development of these particular diseases?
Well, in terms of the development, like in terms of cancer, I've got one of my colleagues, Avnish. He's dealing with cancer and how to effectively administer chemotherapy. So he'll look at the actual drug and how it passes through the system and look at the fluid properties of that in order to, because chemo drugs have a magnetic property. So if you can model how the fluid flows through the system, you can effectively administer the chemotherapy. So he's currently looking at that, and it's quite new work. So he's excited about that, and that's quite interesting developments that could come from something like that.
All right, let's speak to Desmond now. Remember, we are taking your calls on 0891 104 207. Good morning, Desmond. Welcome.
Rowena,
yes.
That lady, okay. What actually, I know I've heard that because I was also very much interested, as you were, how mathematics could be related to HIV, to cancer and other diseases. How can it work there? But now I understand that it's almost on the numerical predictions how a disease can spread. So on that one, I'm asking, how is it? How are the areas, the warm areas of the world? Does the disease spread quicker than the cold areas. Then number 2 is about the wave this time, as we did actually at one time have a mini tsunami here when our beaches were damaged. They had to sort of repair the beaches quick so that when the tourists come in, the beaches will be much better, replacing sand because it was sort of damaged. And the working of the waves as how it washes into the beach, into the coast. All those things are quite interesting, as this lady puts it, that how now the rise of the wave, when the weather is not good. I know when the weather is bad, then the waves will go high.
But what do you mean when the weather is bad? When it's raining?
Yes, when it's raining, when there's wind, when there's wind out there at sea, because that's where I discovered that the sky is always looks like the sea is always, the sea is blue because of the sky. Because when on an adverse weather conditions, you'll find that the sea becomes grayish because of the sky that is gray. Thank you, Rowena.
All right. Thank you, Desmond. Ms. Carvalho?
Yes, let me comment on that. Thank you, Desmond. Thank you for your call. According to the first question you had about the disease spread in the warmer climates as opposed to the more cooler climates, I don't have much information on that. Like I said, I don't specialize in disease spread. But surely, if you look at in terms of bacteria, what I know, so in terms of bacteria and stuff, the warmer climates, you're more likely to have disease spreading and such because obviously your bacteria prefer a warmer, moist climate. So in terms of the first question, that's just my 2 cents on that. In terms of the beaches, I can comment a bit more on that. He was talking about the sand. I remember a few years ago, I think it was in KZN where I think it was near Mshlanga and Belita where the beaches were actually washed up, and it was just before the December break or so, and the beaches were washed up quite high. And in terms of wind-generated waves, that's what I think Desmond was talking about. He says when the weather gets bad, exactly, when it's windy. So there's different types of waves. One of the waves in which Desmond is referring to is something called a wind-generated wave. Now that's a surface wave. So as the wind blows, it moves the surface of the wave, and that propagates forward. Like in terms of a tsunami, tsunamis are caused by different types of events, such as an earthquake. Now, earthquake is just seismic activity on the seabed. So the wave will actually be created at the seabed. So instead of just the top part of the water moving, you actually have a whole column of water moving forward. And that's what creates that big wave coming inland, because there's something called a shoaling effect that takes place. So as we move more inland, you can imagine that the seabed starts to steepen slightly. So it can kind of be seen as like a wedge. So as the water comes and it approaches this wedge, the shoaling effect takes place. And this wave, this big column of water now is hitting an incline. And that's where you get that large pop-up of the tsunami wave, which can measure, there was one that was measuring 100 meters high.
Wow.
That's the monstrous effect of a tsunami. So those are your super waves. But I think Desmond was speaking about, yes, the wind-generated waves. So the sea does become more rough, and it's just the increase in the wind that's creating this wave.
We are in conversation with Ms. Cindy Carvalho, who is a master's student at the School of Computer Science and Applied Mathematics at Wits University. And we are talking about her area of research primarily, but we're also talking about how mathematics can be used to predict and to predict the development of diseases. The center also provides advice on how best to combat those diseases.
thulaganyo e o itlisediwa ke lefapha la Science and Technology SABC Education ka tshwaragano le Motsweding FM.
Magaetso mo thulaganyong ya rona ya Science and Technology re lebeletse baithuti ba mophato wa tota mo kgweding eno re lebeletse baithuti ba mophato wa grade 10 le grade 12 gore ba ka thusega jang mo dirutweng tseo ba di dirang gore di ka ba ungwela ka mokgwa o ntseng jang mme mo gompieno mo sekhutlhaneng sa rona sa Science and Technology re tle go buisana ka gore Center of Excellence e dirisa serutwa sa dipalo go tlhaloganya le go bonela pele kgolo ya malwetsi le go neelana ka maele a gore re ka lwantsha jang malwetsi a me re buisana le Dr. Rahab Khatle go tswa ka kwa Wits University gore tlhalosetsa go le gontsi ka seno a re mogele ka gang fela Dr. Khatle wa mogetswe mo Motsweding FM
ke leboga thata
o tlhotse sentle Doctor
re tlhotse lona le tlhotse
le rona re tlhotse sentle a re simole fela kwa tshimologong re o re tlhalosetse gore fa re bua ka setheo sa Center of Excellence re bua ka eng ebile re lebeletse serutwa sa dipalo thata
setheo sa Center of Excellence ke lefelo le leng gore batho ba itsanape ba dira ka natla go leka go tokafatsa naga ya rona kana lefatshe la rona di farologane mme ka fa o buile re tla bua re lebeletse serutwa sa dipalo ke tla bua ka tse pedi ya ntlha ke Center of Excellence e leng gore le gaela la yona le mkhona mo Wits University re bitsa Center of Excellence for Mathematical and Statistical Sciences ya bobedi ke Center of Excellence e gate ke South African Center for Epidemiological Modeling and Analysis e leng gore le gaela yona le kwa Stellenbosch University ke tla bua ganyane ka SASIMA which is yona Center of Excellence e leng kwa Stellenbosch tiro e ba dirang mo go yona ke go thata ke go ba leitlho le le tona mo malwetseng gore a ska tswa mo taolong ke tiro e ba e dirang e tona go gona kwa Stellenbosch
re santse re le mo ntlheng e fetsang go e tlhalosa gore ka kwa Stellenbosch ba dira thata ba lebeletse gore malwetsi a ska ba feleletsa a tswa mo taolong o ka re tlhalosetsa go le gantsi ka botlalo ka se o fetsang gore kaela ka sone
go na le mekgwa mebedi e leng gore motho a ka lebelela gore malwetsi a ska tswa taolong mokgwa wa ntlha re tla o bitsa re re ke prevalence ona mokgwa o o nka dinomoro gore o nka a survey mme o nka dinomoro tse di tswang mo that survey and then wa di seka dinomoro tse go kgone go fitlhela kitso e botlhokwa ka bolwetse gore bolwetse bo nako e ntse e tsamaya bo fetoga jwang ba ganelela kapa bo fola bonolo kapa bo jwang ya bobedi mokgwa wa bobedi wa go leka go ba litlhele letona mo malwetseng a gore a ska tswa mo taolong ke go lebelela incidence so o lebelela the rate at which malwetse a tshwarang batho ba bantšha ka ona so re tlo lebella a re lebelle gongwe maybe mo kgweding e re leng mo yona re re bolwetse bo rileng bo tshwere batho ba ba 10 kgwedi e latelang bolwetse bola bo tshwara batho ba ba 100 re tlo kgone gore the rate at which bolwetse bo tshwara batho ba bantšha ka ona bo oketsegile so Center of Excellence e leng kwa gona Stellenbosch SASIMA ba lebella thata go seka incidents gore ba kgone go nna le ponelo pele ya malwetsi a ene thata ba lebella malwetsi a leng gore batho ba kgone go phela sebaka se se telle ka ona jaaka HIV jalo le jalo so ba lebella gatekeng incidents me e ba bolella risk ya gore batho ba tshware ke bolwetse bo a ya oketsega kapa ya tshwana kapa ya fokotsega
a re lebelle botlhokwa jwa lefapha la science le technology ga mmogo le Center of Excellence re lebeletse thuto mo Afrika borwa gore botlhokwa jwa ditheo tse ka bobedi di kopane ke jo bokana ka
botlhokwa ba ditheo tsa gore di kopane bo botona ka gore ka ke buile tiro e tona e dirwang ke SASIMA e dirwa ke mo professor Alex Welte gona kwa gona kwa Stellenbosch le badiri mmogo nae tiro e tona ka gore re itse gore HIV ke bolwetse bo leng gore khale re ntse re batla go bo seka-seka re batla go bo tlhaloganya re batla le go fitlhela gatekeng re batla go fitlhela gore re ka bo fodisa jwang re batla go bo thibela le go bo thibela mme ka re itse gore a re kgone go thibela malwetse a mang a re kgone go ha re na le ponelo pele le fa re sa kgone go a thibela re ka kgone gore re fokotse the rate at which a tshwarang batho ka one re ka kgone gore re affecte di-policy tsa boitekanelo ka bolwetse bona bo
Doctor a se ra gore serutwa sa dipalo se botlhokwa thata mo lefatsheng ka kakaretso e seng mo scienceng le bonetetshi fela o ka re tlhalosetsa go le gontsi ka gore botlhokwa jwa serutwa se sa dipalo ke botlhokwa bo bokana kang
serutwa sa dipalo botlhokwa ba teng bo botona ke nagana gore fa re sentse re le baithuti thata kwa bo grade 12 kwa bo grade 11 le 10 go thata go tlhakanya thuto ya dipalo le lefatshe la rona batho ba bantsi ga ba kgone go bona gore fa o dirile dipalo kana fa o dirile mathematics o tlo dira eng mo botshelong o tlo kgone go thusa jwang naga ya rona kana ka lefatshe la rona mme ha ba itse gore o kgone go dira dintho tse di le dintsi tota go tshwana le ditiro tse re di dirang rona for Center of Excellence for Mathematical and Statistical Sciences tse ding tsa dipatlisiso tse re dirileng ke ka technology e ntsha ya go kgona go ntsha di-oil kapa di-gas tse di leng ka mo teng ga lefatshe ka mo tlatse ga matlapa go boteng ba lefatshe tse di leng kwa Karoo gona mo Afrika Borwa mme re a itse ba botlhe gore tuelo ya di-oil kapa di-gas kapa di-petrol gore e intsi gagolo ene e re affecta mo matshelong a rona thata jwang so if rena re ka kgona go ifitlhela oil eo le rona letsatsi ka letsatsi bophelo ba rona lifestyle ya rona le gore tuelo ya dintho tse leng gore di re thusa gore kgone go phela e tlo kgone go tokafala le economy ya rona e tlo kgone go tokafala so thuto ya dipalo e botlhokwa haholo e botlhokwa thata go etsa gore naga ya rona e kgone go nna le tswelo pele le lefatshe la rona le kgone go tokafala
re buisana jalo le Dr. Khatle go tswa kwa Center of Excellence mo tsatsing la gompieno re buisana ka ntlha e botlhokwa thata e ke tsang gore o le mošwa o ntse karolo ya thetso ya gore o tle o ikungwele go le gontsi mo go yone re lebeletse gore Center of Excellence e dirisa serutwa sa dipalo jang go tlhaloganya le go bonela pele kgolo ya malwetse le go neelana ka maele a gore re ka lwantsha jang malwetse Dr. re tshwarele fela jalo re pota ka go kantorong ya dikgang tsa re fa re boa re be re tswelela pele ka puisano ya rona